a lot, and it's the answer button. So whatever answer I previously had, I can hit second, or this one, sorry, it's not second, it's alpha, and then equals, and it brings the answer that I previously had in there, which is going to make sure that I have as many decimal places as possible. So 1.23 meters per second would be the answer. And I only know it's meters per second because it said in the question. You're going to end up with an answer in meters per second. Hopefully that helps you, Alex. That one was definitely a battle with your calculator. If you kind of have sort of confidence in how to do the calculations, you'd probably be okay. But if you're kind of haven't figured out your calculator yet, that would be a really difficult question. I'm going to go back to chat. So that was the last one on page 10. 8A on page 9. Let's go to 8A on page 9. All right. Leave that up for a second in case anybody is interested in it. Although just looking at all of this probably doesn't make a ton of sense right now. But I guess you could always go back and look at the video and see my solution there. If you're having issues with that one. This is right in exponential form. So I want to combine my root here into an exponent. So I'm going to take this 4a, which is still 4a. There's no exponent behind the 4 or the a or outside of my bracket here. So everything in terms of my power is just going to be a 1. And then I have this negative 3. As my root, or the index as we referred to it last day. I kind of have a sneaking suspicion that the answer probably doesn't have a negative exponent in it. So you would have to, at this point, say, okay, my exponent is negative. I had this negative 3 here. I'm going to have to flip it to make it positive. So I don't flip the exponent stays the same. It's going to be 1 over 3. But I do flip whatever the exponent was acting on. So this is going to be 1 over 4a to the 1/3. So that might be where the trouble was coming from in that one. Getting all confused with the question requests here. So hopefully that one helped. Can you do number 8 on page 9? Number 8, page 9 of the learning guide. Number 8C on page 9. 8A, 8C. And then Haley, you've said you do number 9 on page 9 and number 1 on page 10. You don't need to do 8A anymore. Okay. I'm going to jump to number 9 on page 9, if that helps. Hope. Number 9, convert the exponents, then simplify and write the answer as a radical. This is kind of a bit of a tricky question. This goes back to the flower. This is the power roots, the root little rhyme that I mentioned. So flower is the power. I have a power of 2, so that's the power. And then the root is the 3, or my index out front. I'm multiplying this by flower is the power, so the 3 is my power. And then my index is 4, my root is 4. I know I need to add my exponents. So I need to have a common denominator. Common denominator between 3 and 4 is going to be 12. So this is 8 over 12 and a to the 9 over 12. Probably can't read that. And then I'm going to add them together. So I'm going to get a to the 8 and 9, 17 over 12. I'll just keep working this way. Then it says write it as a radical. So I'm going backwards, kind of back to where I started here in terms of radicals, but I've now combined these two things together. So I go back to the idea of flour is my power. So this was a as my base. My power is 17, and the root was 12. So I put it out front. That's good. Maybe I'll do B as well. What do we think? Let's do B. Looks tricky. So what I'm going to do is I'm just going to leave this power of 1/2 out here for now. And I'm just going to deal with everything inside of it. So I'm going to rewrite it like this. So I'm going to go with my A. My A had a power of 3, and the root was 4. And the B had a power of 5, and the root was 4. So just dealing with things in the brackets. Now I go to my basic exponent laws. If I have an exponent outside of the bracket, I have to multiply it by everything inside of the bracket. So I'm going to go a to the 3 over 4 times 1 over 2 is 3 over 8. And b, the 5 over 4 times 1 over 2 is 5 over 8. Now I'm going to rewrite this. There's probably a few ways you could rewrite it. I know I have the 8th root for both of these things. I'll write it like this: a to the 3 and b to the 5. Because my power was 3, my power is 5, so they stick around, and then my root for both these things is 8. I could have written it as the 8th root of a to the 3 times the 8th root of b to the 5. That would have been fine as well, same thing. It's kind of nice to put them under the one radical sign so they're cozy, they have a friend to spend time with under there. So that was number 9, A and B. Number 9 and number 1 on page 10. Don't need to do 8. Can you do 2 on page 10? So 1 and 2 on page 10, and then maybe we'll call her a day. This is page 10. Here's number 1, and here's number 2. All right, so find a number for x that makes the statement true. It's kind of a little bit of problem solving, I guess. I see that I have an answer of 25, and I see my base is 5. So if I just said 5 to the power of what gives you 25, you would say, oh, well, it looks like that's just going to be 5 to the power of 2 is 25. The problem with this question is a lot of times in math, we can give you a process to follow, and it kind of works all of the time. This one requires you to use a little bit of your brain. There's probably some sort of process we could follow every time and it would work out. So I know that whatever's my exponent on my 5 needs to be a 2, because that 5 times 5 is going to give me 25. So right now I have this 3x plus 5. And I need to put something in there so this equals 2. Because I know I want to end up with an answer of 25. Now I can just solve by inspection, just looking at it and think like, 3 times negative 1 is going to give me negative 3 plus 5 is 2. Or I could solve it mathematically. So I could say, okay, I'm going to subtract 5 from both sides. And I'm going to get 3x. That's going to go away. 2 minus 5 is negative 3. I'm going to divide both sides by 3. X is negative 1. So that's one of the way I can do these problems. And Alex, exactly what I was just saying, you are solving by inspection. That's what we call that. You're just looking at it and say, okay, well, it's 25. I know 25 is 5 squared. Whatever that exponent was has to be 2. So if I put in a -1, that gives me 2 in the top. So that's a perfect way to do it. There's nothing wrong with that. The next one here, I know I have a 3 as a base, and it's got to equal 27. So 3 times 3 is 9, times 3 is 27. So whatever I'm dealing with here, it's going to have to equal 3, because I'm going to need a 3 to the power of 3 to give me 27. So I can do the same process again. I can go 3x minus 6 has to equal 3, because I need 3 to the power of 3. And then I can add 6 to both sides. 6 and 3 is 9. Divide both sides by 3. And I can get 3. Or I can solve by inspection. I can say, okay, well, I need to get a 3. 3 times 3 is 9, minus 6 gives me 3. So that's number 1. I think the last one was number 2. If a cube had a volume of, if a cube has a volume of 3,375 cubic centimeters, how would you write the length of one side as a power? So I know if I have a cube, here's my cube, I'm going to have length times width times height, and they're all going to be the same. So the volume of a cube is length times width times height. These are all the same. So maybe I'll just write it as length times length, which is just length cubed. That's why it's called a cube. So the volume of a cube is just length cubed. Hopefully that makes sense. Now it tells me the volume is that, so I'm just going to plug that in. Now this is a lot of work you probably don't need to show for this question, but 3,375 is equal to the length cubed. Now if I want to find just the length, the opposite of cubing something is taking the cube root of something. So what's going to end up happening here is I'm going to have the cube root of 3,375, which is equal to L instead of L cubed. And then it wants me to write it as a power. So I have no exponent. I have an index of 3 or a root of 3. So I'm going to have 3,375 to the 1 over 3 is equal to the length of the side. So maybe a bunch of work that you probably don't need to show to end up there. We've done a bunch of questions like that. I know you've encountered those before, at least with a square in grade 9. So that's something we definitely would have seen before. I'm thinking I'm going to quit there, not quit, end. Don't want to be a quitter. Does anybody have any further questions before we kind of log out here for the day? Just when people are kind of typing. We're done Unit 3. You should get the test done by Sunday and get the review in so I can get you the... Sure. Mr. Ross, can we throw that question back up while I'm talking? Belle didn't get a chance to copy it down. Thank you. So again, you have your test on Unit 3 to do. Some of you still have a test on Unit 1 to do, which is a bit of a problem, but that's neither here nor there. We have just done this Unit 4 stuff. We just started it, so things that you've definitely seen before. And if you didn't even do anything on Unit 4 until Monday, that would be great. That's kind of it for that stuff. I just needed to keep moving with Unit 4. So anyways, I'm sure that's probably good for that question for you, Belle. Jade, thank you for sending me that. I will have a read of it once I'm done here for the day. So if you guys need any help, have questions, let me know. You guys are going to do some English right now. Mrs. Ward is away. She's in a meeting. So you have Mrs. Wyatt. And Mrs. Wyatt is going to do the English all in Blackboard. So you're not going to have the live stream up. You're going to do everything in Blackboard with Mrs. Wyatt. And you're going to do that at probably, we actually, believe it or not, in our little building, we have a fire drill today. We have to do them. So I'm going to go ahead and say you're going to probably start that at 10:30 today because our fire drill is at 10:20. So you have a bit of a break now. And yeah, I won't see you guys tomorrow because you have full English tomorrow. So I'll see you again on Monday. So if you have anything that comes up between now and Monday, send me a message in Moodle and we can deal with it. So hopefully you guys have a great weekend, and we'll see you again on Monday or Friday. What are we doing? Fencing. I don't know if I'm coming. You should go fencing. It'll be awesome. So yeah, have a good weekend. We'll see you later.